Hello, my dear friends and followers. This is Abhishek. I welcome you to my channel Ayodhya Informative. In my previous video, I have solved some examples on nth term of the arithmetic progression. So, in that, I have explained how to solve and how to find out nth term and how to understand the question, and also I have given you some tips on how to understand the question. So in today's video also we are going to solve some examples. After that we will going to solve with the exercise 1.2. Let's get started. If you're before going to start, if you're watching my videos for the first time, don't forget to subscribe and share with your friends. Let's get started. Today's the first question is find the 11th term from the last term towards the first term of the AP. They have given you one sequence. They have given you one AP, that is one list of numbers. That is given AP is 10, 7, 4, so on up to minus 62. This is the list of numbers. This is the given progression. This is the given list of numbers. First, we need to understand what all given in the question. They are asking to find out 11th term from last term. Now, from till now we have solved we have find the terms from beginning. We consider this as first term, second term, third term. But in this question, they have asked to find out the 11th term from last, ulta, that is minus 62. So here, this problem can be solved by two methods. So I will I will explain you both the methods. So the first method is the simple method is write this sequence ulta, reverse order. That is first check whether this is an arithmetic progression or not. The difference between 10 and 7 is minus 3. 7 minus 10 is minus 3. 4 minus 7 is minus 3, so on, and 62. But if you reverse this sequence, if you write this sequence in reverse order, that means if you write from here, if you start from here, then the common difference will become plus 3. How? See, minus 62 and minus 62 to the minus 62. If you add plus 3, what is plus 3? Minus 62 minus 59 minus 56, so on up to 10. Now I wrote this sequence in reverse order. Here this is the given sequence. So this is the question they have given. From this we need to calculate 11th term, but that is to from last. From here the 11th term. From here to 11th term we need to calculate. But from here the difference is minus 3. If you write this reverse order, if you write this in the reverse order, the common difference become plus 3. See, the difference between minus 59 and minus 62, what is? That is plus 3, and 56 minus 59, that is also plus 3, so on up to you will get the last term as plus 3. 10. So this is the first step we need to find out. This is the given sequence. I have wrote this sequence in reverse order with changing of common difference as minus 3 to plus 3. This is the first step. Then the second step we need to consider, or we need to find out the 11th term. How we have to find? Now consider nth term of the AP. What is the nth term? An equal to a plus n minus 1 into d. Okay, an equal to a plus n minus 1 into d. This is the formula to find nth term. But here in the question they have given you to find out 11th term. Hence the n become 11. That's why substitute over here n equal to 11. Here a is minus 62. I have reversed. In the question if you consider a will become as a 10. This is the first term. But according to our convention, I have wrote this sequence as reverse order. Hence, in this sequence, the first term is to be considered as minus 62. Hence, I will write it as minus 62 plus, what is n? 11 minus 1 into d. What is d? Here in this case, in the new sequence, the difference, consecutive difference is plus 3. In the given sequence, in the question, the consecutive difference is minus 3. But here we are solving with the new sequence. That's why I wrote it as plus 3. Minus 62 plus 11 minus 1 is 10 into 3 equal to minus 62. 10 3s are 30. This is 11 minus 62 plus 30. What is minus 62 plus 30? That is minus 32. This is the 11th term of the sequence. If you from the last term, this is the one method we have to solve this problem. First, this is the question given. I will explain you this once again. This is the given question. So this is the question given 10, 7, 4 up to minus 62. In the given question, the first term is 10 and the last term is minus 62. So this is the question given. But we need to calculate the 11th term. 11th term from the last term means towards the first term. That's why I reverse the order of the given sequence as minus 62 and minus 59, minus 56, so on up to last term 10. I reverse. But in the question, the difference is minus 3. If you reverse the order, then the difference will be opposite sign, that is plus 3. If you add plus 3 up to minus 10, this is the question. This is the sequence we have. This is the given. This is this sequence we changed. Now from this sequence, we need to consider or we need to calculate the 11th term. 11th term. This is the reverse order. See this. See these two sequence. I wrote this. That's why from beginning we need to calculate 11th term. From 11th term, if we need to consider this formula an equal to a plus n minus 1 into d. This is the formula to find nth term. So here the given n, the value, the term value, the position of value we need to consider is 11. That's why I wrote it as n as 11. A11 is equal to minus 62. Why minus 62? Here the 62 as is considered as the first term of the new sequence. That's why I wrote a as minus 62 plus n is 11 minus 1 into plus 3 d. If you consider, if you calculate these two, the 11th term is minus 32. This is one method of solving this problem by reversing the sequence. So this is by reversing sequence and changing the sign of common difference. This is first step or first method. Next we will see the next method, how we can solve this same problem without reversing the sequence. In previous method I have reversed the sequence and reversed the sign of the common difference. Here in this method I'm not going to change the sequence. From this sequence only we need to consider the 11th term. How? Let's see. If you consider a sequence straightforward, first we need to calculate how many number of terms are present in the given sequence. That is from first term, that is 10th, to the minus 62. From 10 to minus 62, how many number of terms are present in the given sequence? That is the first task. If we have to calculate the 11th term in the same order, in the same given order, let's see how we have to find out. The difference is minus 3, common difference is minus 3, and a is 10. In this case, a is 10. This is the second method. Now, if you have to calculate the value of n, let's see how. An equal to a plus n minus 1 into d. An is the last term of the sequence, but in this case we know what is the last term. In this sequence we know the value of the last term, that is minus 62. That's why I am writing an as minus 62 equal to, here a, the first term a, the value of a is 10. Write this value. N, we don't know the value of n. We don't know the how many terms are present. How many terms are present in this sequence from the first term to last term. That is the task we need to calculate over here. So keep it as it is n, and value of d. What is the value of d in this case? It is minus 3. So minus 3 minus 62, 10 plus substitute or multiply term by term, that is minus 3 into plus n, that is minus 3n, minus into minus, that is plus 3. Now minus 62, 3 plus 10 plus 3 is 13 over here, 3n. Now if you shift all the negative sign one side and positive one side, what we get? Shift this minus 3n to this side, it will become plus 3n, and minus 62 to this side, it will become plus 62. See, 3n will be equal to 13 plus 62, 3n as it is. What is 62 plus 10? 13, that is 75. Now, n will become 75 divided by 3. 3 ones are 3, 25s are. Therefore, n will become 25. Now, we have to conclude this as n equal to 25. It means there are 25 terms are present in the given sequence. That means from the first term to the last term, there are 25 terms are present over here. So this is the first step we have solved. Let's move on to the next step of this method. We have calculated n as 25. Now see here, they have given you to find out 11th term from the last term, from the reverse term, not from here 11th term 1, 2, 3, 4, not from here. We have to starting from 1, 2, 3, so on up to 11th term, from this term to 11th term. Now we have calculated n as 25. There are 25 terms. If you subtract a 11th term, if you subtract from here to 11th term, these 11 terms, imagine what value we are getting. Minus 11 means it will become 14. Okay, remaining terms are 14. In terms of n, how we can write it as 14? That means in terms of n minus 1, that is 15 minus 1 equal to 14. That means from the beginning term, we need to calculate 15th term from the starting. From first term, we need to calculate the 15th term. So see here. Now an equal to a plus n minus 1 into d. An, what is n here? N is 15. A is 10 in this case. 15 minus 1, 14. So last term is 14. From beginning it is 15th term. From the last term it is the 11th term. See here. Beginning it is 15th term, which will be equal to 11th term from last. If you start calculating from last term, this will be 11th term. It will become 11th term. If you start calculating, if you are counting from starting 10, it will become 15th term. That's simple. 15 minus 1 into d is minus 3. A15, what is the last term over here? A15, don't know, keep it as it is. 10, 15 minus 1, that is 14 into minus 3. 10 minus 14 3s are 42. This is 10 minus 42 is 32. This is the second method. We have to solve like this. So if you have any doubt in this problem, let me know through the comment section. Let's move on to the next example. Next example is, see here, the sum of 1000 rupees is invested at 8% of simple interest. Simple interest, PTR upon 100. This is the formula to find simple interest. So per year, this is the first data given in the question. 1000 rupees is invested at 8% of simple interest. Simple interest is given as 8% and sum of 100,000 is given. Sum is given as rupees 1000. So this is the data given. Now calculate the interest at end of each year. Calculate the end of each year. Do these interests form an AP? If so, find the interest at the 30 years making use of this fact. So here the question is simple. Every year a person invested 1000 rupees at the 8% of the simple interest. So from first year 8%, second year 8%, third year 8%. So first we need to calculate 2 to 3 years of simple interest, how much amount he will get. Now if that sequence of the whatever we have calculated the values, if that values form an arithmetic progression, then we need to calculate the simple interest at the 36th year, 30th year. Let's see. Before starting actual problem, see here the formula to find the simple interest is PTR upon 100. This is the formula to find the simple interest. P is profit is 100, that is P is 100. T is time interval. R is rate, that is R by 100, that is 8 by 100. Substitute. Now for first year, the interest will be R. Time is for first year the interest, the time is t, time is 1, and p substitute 1000 into r8 into t is 1 for first year divided by 100. These two will cancel over here. 10 into 8 is 80 rupees. So if he invests a amount of 1000 for 1 year, then he will get 80 rupees of simple interest. Then for second year, how much? For second year, same. 8 into, for second year, the time interval will be changed to 2 and divided by 100. These two will cancel. 8 to the 16, 160 rupees. If he continuing investing amount for second year, then he will get amount of 160 rupees. Similarly, third year, 1000 into 8 into the time interval is 3, that is 100. These two will cancel. 8 3s are 24, that is 240 into. We have found out these three values. Now check whether these three values forms an AP or not. See here, 80, 160 and 240, so on. This is for first year, second year, third year simple interest. Now check whether this sequence is an arithmetic progression or not. In order to find an arithmetic progression, if given sequence is an arithmetic progression or not, we need to check the common difference. If the common difference are same between any two consecutive pair, then only that sequence forms an arithmetic progression. See over here. 80 in 160 minus 80, how much? That is 80. 240, the difference is 240 minus 160 is also 80. Now if you continuing adding 80 to 240, what is 240 plus 80? That is 320, so on. Since the common difference between any two consecutive pair is same, that is fixed as 80 rupees, 80 rupees, 80 rupees, hence this forms an arithmetic progression. First condition is checked. So if this forms an arithmetic progression, then we need to calculate the simple interest at 30th year. 30th year. How we have to calculate the value of simple interest at 30th year? See, we know the first term as we know the first term A, and we know the common difference, that is 80. We don't know, we have the value of n. All the value we know. Just simplify the formula. Formula to find nth term is an equal to a into n minus 1 into d. Here n, the position of the number. What position, at what position we need to calculate a particular number, that number is taken to be as the value of n over here. So the term at that position, what a term is present, that term is considered as an. So here n is considered as 30. A30 equal to a is 80 into what is the value of n, that is 30 minus 1 into value of d is 80. A30 will be 80 as it is. 30 minus 1, that is 29 into 80. Sorry, this is plus. This is 30 minus 1 is 29 and this is 80. Now 830. If you simplify these two equation, you will get it as 2400 rupees. At 30th year, he will get the simple interest of amount 2400. This is how we have to solve. I will explain you once again main things over here. They have given you a simple interest at 8%, and they have given you a sum amount he invested at the starting at 8%. So whenever in a question of these kind, or whenever in a question in the chapter arithmetic progression, if you find the keyword, if you find the word simple interest, then you need to consider the formula for simple interest, that is PTR upon 100. So this formula needs to be considered whenever you see a keyword in the simple interest in the problems. So this is first. From this formula, we got one sequence, that is 80, 160, 240, 320, so on. After getting the sequence, we have checked whether the sequence is in arithmetic progression or not. We have checked. Since the difference is same, since the difference is fixed, hence this sequence is in arithmetic progression. That is second step. If this is arithmetic progression, then we need to calculate the simple interest at the 30th year. That I have solved here. The value which we need to calculate, a year which we need to calculate, that is taken as n, the value of n. So all the values are substituted in the nth term of the arithmetic progression formula, and if you calculate all these things, you will get the simple interest at 30th year is 2400 rupees. This is the second problem, second example. If you have any doubt in the example, let me know through the comment section. Let me move on to the last example of the question. So example is, in a flower bed, in there is a one flower bed, there are 23 rows plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? So the question is simple. Just we need to understand. There is a one flower bed, that is in first row there are 21 flowers are present. In the second row, sorry, 23. In the second row there are 21 flowers are present. In the third row there are 19 flowers are present. In the last row there are 5 roses are present. Now we need to check whether this number of flowers present in each row forms an AP or not. See, in the first row the flowers present are 23. In the second row 21 flowers are present. In the third row 19 are present, so on up to last. From last row, in the last row there are 5 rows are present, 5 flowers are present. So this is the given sequence from application question. We need to consider this is the sequence. Here A is considered as 23. Now check the difference. 21 minus 23, that is minus 2. 19 and 21, this is also minus 2, so on. Now if the common difference between any two consecutive pairs are same, then we need to conclude this sequence as an arithmetic progression. Here minus 2 are fixed between these two consecutive pairs. Hence this AP, this arithmetic progression forms an this sequence, this list of numbers forms an arithmetic progression. This is the first step. Then what they are asking to find out in the third row and so on. There are 5 plants. How many rows are present in the flower bed? Here there are number of flowers, but we need to calculate how many number of flowers from the first row to the last row. How many flowers are present? That is, we need to calculate over here. See here, an equal to a plus n minus 1 into d. An is the number of flowers present in the last row. Last row, this is the last row, this is the position. In that position, how many number of flowers are present? That is 5 flowers. That is, last term is 5. That's why I wrote it as 5. First term a, that is 23. N means number, how many in the total, in that bed, in that flower bed, how many total flowers are present from first row to the last row. That is the task. Keep it as it is, and d is -2. 5, 23, multiplication, term by term multiplication. -2 plus n, that is -2n, minus into minus plus 2. 5, 23 plus 2. What is 23 plus 2? 25 minus 2. Sorry, 2n. Shift this minus 2n to the other side and plus 5 to other side. See, 2n equal to 25 minus 5. 2n, 25 minus 5 is 20. N equal to 20 divided by 2. 2 ones are 2 tens are. Therefore, 10 rows are present. From starting the first row to the last row, there are 10 rows are present. 10 rows. So this is the number of 10. I will explain you. There is one flower bed. In that flower bed, there is one row. There are some rows. In that first row, in first row there are 23 flowers are present, and in second row 21. In the 19 in third row there are 19 rows are present. Similarly, so on up to in last row there are 5 flowers are present. So this is the given data. Now we have to consider individual flowers from individual row. How many flowers are present from each row? From first row there is a 23, from second row 21, third row 19, last up to this is last row. 5 flowers are present. Here the task is, in such how many flower rows are present? Rows, how many rows are present? That is the task given. Here we considered a as 23 and common difference -2, and the row which we need to calculate, that is taken as n, and how many flowers are present in the last row, that is considered as an. So after solving all these things, we get it as n equal to 10. So there are n equal to 10 numbers of rows are present in one flower bed. So this is how we have to solve these type of example. So this is all about the examples given in the textbook of 10th standard state syllabus. In the next video, I am going to start with exercise 1.1. So if you are watching my videos for the first time, don't forget to subscribe and share with your friends. If you have any doubt and any queries, please let me know to the comment section. Thank you.